Good evening to all of you. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Also, we have launched our Reactor group on LinkedIn. Please feel free to join the group to get the latest update on session happening on Reactor. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel within 3 to 4 days. I will share the link to our YouTube channel in the chat section soon. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Vivek, our speaker for today's session. Well, all of us know Vivek by now, so no introduction to be given to him. But then, yes, of course, Vivek is a tech enthusiast and an open source contributor with around 15 years of experience in the software industry. He works at Microsoft as a senior cloud advocate. But for now, I will hand over to Vivek to begin the session. Over to you, Vivek.
Thanks, Rashmita. I'm just trying to share my screen. Just give me a minute. So you can see my screen.
Yep.
Is it my slide? You can see my slide, right? Rashmita?
Yes.
Perfect. So yes, just to introduce myself for people who don't know me. So I'm Vivek. I started my career 15 years back as a software developer in IBM as in India Software Labs. Then I, fell in love with DevOps and became a DevOps solution architect at HCL. Spent some time on enterprise DevOps, building enterprise DevOps from end-to-end DevOps there from a solutioning perspective and also designing perspective. And then I was head of DevOps at Blackberg. That's a startup. And then I had my own startup. Being a developer advocate at DigitalOcean at Microsoft. This is my second role at Microsoft. First role has been more of developer marketing, from a strategy and investment perspective. But this is my second role at Microsoft, where I'm a senior cloud advocate in cloud and AI engineering team. So as Rashmita said, uh, do the event check-in. It's very important for us because you get all the content which is being delivered today, and not just today. You'll also get the content which we are delivering for this specific series within the Azure Happy Hour. So just go to this event check-in link and key in the event ID, and you will get access to the content which is there. I will also share the content, but check-in it will directly, you can directly access it on your own. And then, there is LinkedIn group, as Rashmita mentioned. Please make sure you join that group. So I'm going back. Okay, today I'm going to, walk you through, something like I'm taking us back like 6 to 7 sessions back, where we started defining what is DevOps, and then we learned all the essential skills which are required for DevOps in today's world, specifically from Kubernetes specific. So we did talk about the containers, the things which is there from a container registry, the build and release from GitHub Actions to Azure DevOps, and then we did talk about Terraforms, Kubernetes in the production, how do you set it up and other things. And we did talk about monitoring and logging system last time. From Grafana also, we spoke about a little bit of Grafana and other things. It was more deep dive session for Azure monitoring as well, right? So this was the plan, right? So we wanted to learn how DevOps, example DevOps workflow for Kubernetes, and this is exactly what we went through. Like each step, we deep dive into each of these sessions. So if you are looking for, if you want to go and access those sessions and also the learning materials which has been shared, so that is something which I can share here. So this is a GitHub repo for that. I have each and every session which we did from September, specifically from what is DevOps and other things, and some books which you can read and deep dive into Docker. And then we did talk about specifically for DevOps engineers, what are the things you need to know from a cloud perspective, and then Kubernetes deep dive sessions. We also did CI/CD, and infra, specifically Terraform and other things. uh, all these three sessions I need to update it, but I'll update it in this week, so that you can go back and access this. But everything is here. So today is the last session. Basically what we are doing is we are connecting all those things which we have learned, specifically from release perspective. You have a code, you are releasing it, and Terraform is making sure that you have provisioned your cluster, and you have container registry, and you have monitoring system set up, you have policies set up. And we'll also see an example of how a developer can debug the Kubernetes cluster. While we do have a deep dive session of that as well in tomorrow's session, which is Azure Kubernetes Day, which is starting at 10 a.m. tomorrow morning, with with deep dive session on the Kubernetes from Azure specific. And then we will obviously go into a lot deep discussions with Kubernetes bridge and other things which is coming up. So this is the flashback, right? So we did 8 sessions with all these structure in place, right? So you know I just want to refresh a couple of things. We did define what is DevOps. So DevOps is definitely it's people, and it's process, culture, and technology and tools, whatever we call it. So it's more important. We defined was 50 to 40, no, 60% it's culture, and rest is just the process, tools, and how we adopt technology, how we do the automations and things like that. Net, there are three different things, three pillars, which is defined for DevOps. One is continuous integration, where you have the code and you're pushing the code. Once you push the code is built, and it gives you the report saying whether how exactly is this code good this code is with the rest of the code which is out there. So that is what continuous integration is all about, right? So developer is getting the feedback as soon as the code has been pushed. So that is one. And the second part is obviously the continuous deployment and delivery part of it. So that means from a continuous delivery, where you have a lot of control over your deployment, right? So basically you're pushing code, and you have a control over execution of this code in production. So you basically you have you click on a button, or you do something where code is going to the production. And continuous deployment is all about making sure that the code goes directly into the production, so without anyone actually controlling it. So this is from a delivery perspective. So you have the code, you push the code, and the code is getting built and gives you the feedback. As a developer, you get the feedback of your code integrated with the other services and others code as well. And then there is deployment part of it, where it is getting deployed into different infrastructure. It could be a QA, it could be developer, it could be production, pre-production, different environments are available. So for that, to build those environments, to manage those environments, you use infrastructure as a code, configuration management tool like Ansible and other things, infrastructure as a code like Terraform and other things to provision and manage the provisioning and other things. We will touch upon all these areas while we do the demo and other things as well. So this is different pillars which is there, and then there is the third one is obviously the continuous learning and the monitoring system which is out there, right? So it's not just about pushing the code to the production, but it is also about making sure that the code is running properly and there is no issues, and if there are issues you are catching the issues. It's not just about catching the issues, it is also about auto remediation, like how are you fixing those issues with automated automations. So these are all these things is completely taken care by DevOps, right? You build complete automation of this in the cycle. It's called as workflows. DevOps workflow is what where a simple piece of code is going into production, and in production you are basically looking at the code and also managing the code and getting back the feedback of the code, either through customers, either through certain customers, to make sure that it is all fine and other things. We will also touch upon while we do the deployment to Kubernetes. We will touch upon different kinds of deployment strategies which you can pick, and I'll also show you the code, GitHub Action code, where you can define all these things and set it up for production, right? So those are the demos which we have. So this is just a definition of DevOps just for starters. Since we are doing, it's kind of, we are going to merge everything we have learned from a skill perspective for each and every component we did learn when we did last 7 sessions. So this is the session where we are merging everything. So I just wanted to give a perspective to the DevOps again, and then we'll go back and see how to do it. So I'm going back to this famous diagram which I have. So I've been using this diagram almost like all seven sessions, right? So there is QR code for the GitHub repo as well, so you can scan and take a look at it as well. So today, what we are going to do, right? So the first part, we will take the code, and there are two types of code. If you see this diagram, right, there is your source code, that means your application code, and then there is Terraform code. As I told you, Terraform is a infrastructure as a code, right? It's basically your coding the infrastructure itself, right? So you have the infrastructure code, and then you have your application code. Both the code we will use and build provision the cluster, and then we will use this source code through GitHub Actions. Both, anyways, building both, we will use GitHub Actions. Through GitHub Actions, we will push the code to Kubernetes, and then we will see, obviously, in between, while we are pushing, there is container images which needs to be built, and there is container registry which we need to use while pushing it. And then we will see some kind of activities with respect to monitoring and logging, how to do it with Azure monitoring for containers in a section. And then we will see how to enable policies. That is one thing which we'll go back and see how to enable policy, and when you enable policy, what happens and other things. And then there is a amazing thing which we can do is Kubernetes dev cluster which is there. That, I mean, I'm not talking about the dev cluster. So I'm going to use the production cluster itself, where I'm going to create Kubernetes for, bridge for Kubernetes, in fact, so that I can create from a microservice app which I have. I can divide that app, create it locally, debug the app locally, add breakpoints and other things, and then see how exactly it works. in the production, right? So this is going to be the, a lot of demos of that. So we will hop on to different different technologies and tools and services, etc. So stay with me on this. So let's go back and see how to get this started, right? So where do we start? So this is the GitHub repo, which is there, which I showed you. Just go back and see if you can, get access to all of this. Let me get started with To-Do app, right? So this is a To-Do app, simple To-Do app, which I have, and I have the leverage to um, I have the code for everything. That we will go through the code, application code later. The first thing we will do is provision the system, right? Provision the cluster which is required, right? How do we do it? So as I told you, Terraform has different kinds of things. So let me open the Terraform code, which is there, so that we can go through the code, understand the Terraform. There's my Visual Studio. Yeah, why am I going here? I'm not able to click this. Okay, open my documents. We have repo. Let me open this. Okay, so this is my code. Okay, so you can see that I already have, there is a symbol for Terraform. That means I have Terraform's, Terraform extension installed, which is very important because it does verify your syntax. As we spoke last time as well, the Terraforms is obviously about a HashiCorp code language. It has its own different language, and it does come with providers. So it's nothing but HashiCorp has designed a couple of providers where it needs to connect and work with, right? So Azure RM is resource manager. Azure resource manager is what it is called. It's one of the provider, and you can see there is a provider which I have configured here. This code, we have configured it, and then there is most important thing which we discussed last time as well. If why it is very important to have Terraform, right? Terraform is more about provisioning your infrastructure. Think like this: there is a person A who is provisioning the infrastructure, and he provisions the Kubernetes production infrastructure which is required, and he's maintaining it. And the state of this provisioning has to be stored at some place, so that person B can upgrade this provision, right? So a person like B coming in and upgrading this provision, whatever was provisioned for scale and other things, should be enabled, right? So how do you do it, right? It's basically only if person A, when he creates the provisioning, when he does the provisioning, he has to store the state, and the state is stored in some location. So state, I'm storing it in, if you see here, I'm storing it in storage account of Azure and giving it some name and resource group and whatever resource group I'm using it, and I'm storing it here. Okay, and now now I have the provider been set. Now I have the backend data where the state has to be going. It has been set, and all I need to do now is to call the resource, which resource you want to provide. So if you go to the provider's documentation, there is already a list of, we have seen that in the previous sessions as well. We've done the deep dive session for Terraform only. So I'm just giving you a overview of it again so that you can see we are connecting everything together today. So you can see why it is required. So there is resource, and for bunch of resources which is required. So here I'm choosing Azure RM for Kubernetes cluster, but you can choose different resources. It could be VMs, it could be different resources which we have. So you can see the list of resources available from Azure RM perspective, and you can see that. And it's just giving a reference name here. So okay, I'm just giving a reference name wherever I want to use those names. If I have to use this resource, I can just say, instead of central US, if I had created a resource group, I would have just given the details of Azure resource group dot example dot location, something like that. So that example we did discuss as well. So this is a structure. So I'm just giving the name of the Kubernetes cluster, where I want to create, what is the default one. So this is very important to see. There is maximum count is 6, minimum count is 2, the node number of nodes where it can scale up to, and other things which I have set, and then I'm just executing this Terraform, right? So this is the structure of the manifest file. So where you're telling, this is what I want from an infrastructure, go and provision the infrastructure. So this is what you're telling in the Terraform. This is very similar to the Kubernetes, right? Kubernetes is also similar to this, right? It's a declarative, not an imperative tool, right? When I say declarative, it means you are declaring what you want, and rest is taken care by the service which has been used. Like for Kubernetes, it's Kubernetes cluster server, which is taking the input from you, like this is what you want, this is the YAML file I'm going, resources I want, these are the pods and number of pods I want to build and other things, and it will take it up, and then it is going and deploying it, right? So I have the manifest file ready. Now I have uh, there is a GitHub workflow. Where can I create this workflow? So it's very simple. Let me go to the GitHub. um, Here I go to Actions and create a new workflow, and you can either use the workflows which is already pre-built, or you can either use your own, set up a workflow for yourself, and add the code which is required to do the GitHub Actions. So I've already done that, so that I don't want to spend time in just provisioning a Kubernetes cluster. So I've already done that. So where do I see the code? The code is already under .github slash workflow. So I go to this, and while we are here, there is Terraform. Let me click on Terraform. Okay, now there is uh, just bit of thing to understand GitHub Actions as well. We did deep dive into this as well, but just to understand for first timers, it's basically these are set of instructions. You are giving instructions to run your code, automate your code, automate your workflows, right? So through GitHub Actions, right? When some event happens in a GitHub, you want to run this specific code, right? So there is, Terraform, I'm giving an on workflow dispatch. So this is basically manual execution. It's not a on push, or you push a code and it executes. And this is a manual execution, and I'm running this as manual execution. And you can see this, there is very um, important thing which is here is the secret, client secret and other things which you need to generate. I can share the command for you to generate. It's basically a simple command onto your username, and you just create a command and you just run it, and you will be able to get all the details of this secret, client secret, subscription ID, tenant ID, and everything. Where do you provide all these things? You go to the settings here, and when you go to the settings here, there is secrets, and here is where all the secrets have stored, either from Azure credentials to passwords, username, client secrets, client ID, everything I have stored here. So let me go back to the code. I hope you can see the code. So it's very simple steps. Terraform does this very simple way. So I just need to run GitHub action checkout. So actions is already been, so whenever there is a use, that means that there is already a pre-built template to run couple of commands. So this is how you can do it. This is very simple, like you have checkout, that means you check the code out, and also you can see that you're setting up runner. So when you see the runner, right, that means runner is nothing but an infrastructure. So whenever you want to run something, you need an infrastructure, and this is what the infrastructure is. So it is basically Ubuntu. You can use Windows, you can use Mac, different things which is provided by the GitHub team, right? So that is something which you can take. So, and then there is, then you are using HashiCorp's code. HashiCorp has also defined a pre-built action, that is to set up Terraform. That means it uses all the environments and set it up using all these data which is required to access the Azure APIs to run that specific things, right? It to set it up, and then it does init. So what does init means? It initializes, it runs, it verifies what needs to be done, and it verifies if all the required information is available, all the required provider is available. So when I say Terraform init, it goes back and verifies whether the whether I have defined it, Azure RM, it is available, or any other things which I have added in here, all the things are fine and it is available to use. And then there is format check. It does the format checking, and then it creates the plan. So when it creates the plan, it tells, it tells the it tells the user that this is the plan, and this is what I'm going to do, these are the changes. So whenever you create something, it verifies when you create a plan, it verifies with the previous state. If you're running it for the first time, the previous state is always 0, the first state is always 1. So when you once you have run it, there is always 1, right? So there is state is already stored at some place, and then there is apply. That means you apply this plan, and obviously auto save the state. So when you do this for the first time, when you do this, let me show you how it looks in the, where is the storage account. In my storage account, there are containers. Under the container, you can see there is vs data. Under this, there is the first state. So it is already created the first state. The state is available here. Okay. So I've run this once. So when I go back to GitHub Actions, if you go to my Terraform plan, so you can see this. I've already run this once. So when I've run this, it's obviously has done all the things, and it has stored the data in the storage account. Now if I am rerunning it, it's basically I need to change the state. So how can I do that? I'll go back, I'll go to the to do app, and we will see the manifest file we have. So if you see this, we have maximum 6, maximum 6 and minimum 2 nodes, right? That is what we have defined. And say for example, a different user wants to change it, he'll just go and updates this one and run it, and the code has to change it, right? So basically if I go to the Kubernetes, which is already been deployed by the Terraform, if you go to the node pool, if you go to the defaults, you can see there are 2 nodes, right? So if I click on this, it shows what is the scale, minimum 2, maximum 6. Okay, so this is what current state is, and I want to change the state. So I will go back, and we will change the state to 7 and save this. So there is a change in the code. So when there is a change in the code, what we need to do, we need to publish it, GitHub status. Uh-oh, I made a changes in the static API. What changes I made here? Launched, if did launch from here. We will with the file created modified. In fact, so it's okay. It's already there on the GitHub repo, is it? Okay. No, it's not there. Package. That is good. Okay, it's there. Perfect. Sorry. So let me. I thought it is not more added. So let me add and commit. Before I do this comment, let me pull something if there is something. Keep deploy. There were some changes in the code, so I'm just pulling it. Okay, so let me go back. GitHub commit fnm code changed node code changed. Okay, we did change the code. GitHub push. So now we are pushing the code. The code has been pushed. Note that GitHub Actions will not run unless and until I run it, because we set it up as a push, right? So it is basically uh, it's on dispatch. That means I have to push it. So I have to go to the actions and go to the Terraform, and hopefully it will run now, and say run workflow. And when I do that, it will update this. It will show up here. You can see this, and it is in the queue. It is running. Hopefully it will run. So if you see this init, it's basically verifies all the RM, which is the provider is there or not, and all those things. It verifies it, and then it says this is what has changed. The state has changed. You can see here. So you can see the state has changed from 6 to 7. And did fail. The reason is refreshing. Object have changed outside of Terraform. There is oh, okay. So I made a couple of changes to my cluster. So that is the reason why it is saying I have changed a couple of things, couple of settings which was done in the Terraform. So there is a change in the state, but it is not captured here. So that is the reason why I cannot run this. But you can see this, I did enable policy. I did, a couple of like log analytics. I created log analytics. I enabled monitoring system and the various things on it after creating through Terraform. But in practice, it's basically you should code everything into the Terraform and then do it. Because I did, enable all these things, I'm not able to run that specifically, but otherwise I'll have to code all these things now and make sure it is all set it up again. So making this will not be able to update, but we did this demo anyways. We have it in the video section when you can go to the um, my repo there, and you can see the demo. of this, when you go to the DevOps for all, I will be updating it here, but here if you come to this 29th, we did this demo anyways. Cool. So this is, I mean, it should update the, basically what it will do is, I wanted to show you how it updates 2 to 7. But as of now, since I messed up the state of the Kubernetes, because I created so many things here. So I enabled policies and a lot of things for the demo after doing the creation of the Kubernetes cluster. So that is the main reason why, I could not update it. So if you see, as I told you, it verifies the state. So this is where the state was, and it is basically, is it containers. So it's a good test that it is basically having the state in a JSON format or something, and you can see all the information. It is here, and this specific state, it verified to my GitHub Actions which we run. Was not here, sorry, not here. Ta-da, ta-da. Which is it? Yeah. So here it did verify the state. So it did clearly mention to me that you have added profile policy, I've enabled the policies and everything. So this is, I just wanted to demo how you can change the state of a cluster just by using the code which is there in the Terraform, and you make changes to the code in the Terraform and it gets enabled in your infrastructure. Here it is more of infrastructure as a code, like you're managing the infrastructure, right? So that is one area. Now we will come to your application, right? So there is a app which we have. So we have built the app. So this app is very simple app. It has a front end. We'll see the app so that you'll see the, basically you'll see the front end, how exactly it looks. Where does it come on? Get services. Okay. So you can notice that on my to-do app namespace, I have 1, 2, 3, 4, 5, 6, 7, 7 pods which is running. If I go to this IP address, I can see this, right? So this is a simple to-do app reactor I've created. It's basically an extension of to-do MVC app, which is there. Say for example, you have something, you know, take a cloud skills challenge is one thing. It will just update here, and there is stats. When I click on stats, right, you can see how many created, completed, and other things. So when you say completed, when you click on completed, it will show here stats as two completed or something. So it's basically updating the database and other things. So you can see it's a kind of a microservice where here it's a link to different service. Here it is main front end service. So that is the reason what you will see here, and there is a queue and other things which will, once you update, it sends the data to the queue and waits and it updates, and all the things happens in the cache and other things which is used. So simple app to run your code, and I have the code, and now as a developer you have built the code, and what you need to do is you need to push it to Kubernetes cluster, which was created through Terraform, and it is there, and you need to push the code there. And how do you do it? And obviously in a real world scenario you have different environments to push it, or within the bigger Kubernetes cluster which you can bring up, have different namespaces within the cluster, calling it as dev namespaces, different namespaces, isolating isolating your cluster itself, or you can have separate clusters. It's based on your strategies. Um, so that is one. So here the code I have, the code has to be built, right? So simple as a developer, what you will do is you will go back here and you will build the code. So this is my, say this is my repo, right? um, in the repo, what you will do, there are different services which is there. Say for example, there is front end service. I will go here and you can see when I do a Docker image, I have built all the code. So you already Docker files are available to this specific application. All I need to do is Docker build, and I need to give the command and build it, and then obviously push it to container registry. So here in my Azure portal, I have to go and create a resource where you just go and create a resource, and in that create a resource you go to containers, and under container you can see there is container registry. I have created a container registry. You can give any name, DevOps prod, some name and all these things, and whatever you want, from a basics to standard and other things. Select and just review and just create. So I have already created one. So basically if you go to all resources, I'm not creating a new one. I already have it because I've used it Wikibytes. Here it is, and you can see that it's already created, it's been used, um, and you can see different set of applications has been deployed. So this is built and already uploaded here. How you can do it within from your system. Say for example, you do the docker build command. Once you build it, you can use the VS Code extension, docker extension, and just go here and take this image and just right click on it, and just make a push. And if you are connected to Azure, it will obviously select all the things which is required from the Azure perspective. So just do the push, and it will select the registry where you want to push it. So this is the registry I want to push it. I'm going to select it and just enter. It will start pushing the code. So this is how you can do it from your system. So, but that is not our goal, right? Our goal is to just do with the code and just push the code to um, go to the so push the code to GitHub repo, and the moment it goes to the GitHub repo, I want to run it. I want to do the continuous integrations and then run the deployment and push the code to production. So no manual interventions and other things. It's a direct release to the release code to the um, Kubernetes cluster, and we will see this different strategies how to release it. There are in Kubernetes cluster you can have different strategies for releasing it. So let me open the code. This is the repo, this is the code, right? So is it already open? Yeah, why it is not going? Okay, so this is, did it open? Let me open it again so that there's no issue. Okay, this is the one only. Cool. So let me go to front end. Front end has a couple of code to do app, and we can change this. We will change the code. As a developer, you keep changing the code, right? So you change the code. Say to do app at to do app at React. I'm adding Bangalore as well. So just making it smaller as well. We'll make it 2. We'll make it 2, right? So this is a code which will make save. And when you save the code, what happens? You need to push it, right? So we'll come back to this and you will push the code, GitHub status, there's nothing, GitHub pull, it's all should be updated, perfect. This is a best practice, pull it before push it. So add GitHub commit, change code, right? And then that's the most difficult part, right? When somebody asks you to push it with a comment, you'll start thinking what needs to be there. Git push, right? So you're pushing the code and the code gets pushed. And now, ideal case, the code basically has to run from a actions perspective. For some reason, I made sure that this GitHub action as well is triggered from my end because it was on push. I have moved it to workflow dispatcher because I was making a lot of changes, playing around with the code and other things. And every time I do the changes in the code for the GitHub actions, it does build the code all the time. So I just wanted to, make sure that it is run through execution. But now we will go through this specific GitHub Actions code, which is pretty straightforward as well, but also requires a little bit of understanding. So this is on dispatch, so it is simple. We did this. It is just a description, and it is not required, and it is very simple. Like whatever you type here, it will take it. But this is the most important thing where I have defined a couple of environment variables. So you can see my registry name, which is container registry name, and there is cluster name, which was created by the Terraform. I'm using that cluster name into this. And then there is cluster resource group, which I'm taking in. And then there are namespaces, then secret name, which I will create now. And then there is app names, which I want to run. There are 4 different tabs as I showed you in the code base, right? There were front end, there was work API, stats API, which was a separate kind of a microservice, the front end service and other service, and then there is different things like queues and RabbitMQs, and there is worker. Which is acting as a different thing, and then there is front end and database API, which is getting the data from the MongoDB and other things. So it is taking all this, and obviously it is using the runner, and it is capturing through this action. So this is the use of the checkout. Checkout is nothing but it brings the code onto this runner, that is the infrastructure, and then obviously does the registry name and other things. And then this is the 4 amazing commands, which is build and push to the container registry I have shared. So this container registry is nothing but the registry which I showed you. I created one registry, right? So that is the one where it is going. So all these images you're building every time you push the code, if it was on push, uh, not dispatch, the moment I push the code, it used to get built. You can run the scanner, you can run various things, and then there is set context and other things, which is required. You set the context for Kubernetes service to be used. This is very important. So what this is, so this, as I told you, this is already pre-packaged by the Azure team, right? It is whenever you use with this keyword, you are actually packaged. You can use the package already pre-built. So what it means is go to github.com/Azure/ the keyword which was there, set context. So you can see the code is here and there is action.yaml. So if you click on that action.yaml, you can see the usage of it. So every time you want to use something like this, so go to this usage and you will see what needs to be done, right? So basically you can see, okay, it requires a credential which is required. While setting the context, it requires credentials. Well, it requires the resource group name, it requires cluster name, and this is how it works, and this is how you can use it, right? So that's the that's the importance of this. So you are doing that, and this is nothing but a simple command, kubectl command, to verify whether the namespace exists or not. You use it with double try run. It is basically not running it, but it verifies whether it is there or not. If it is not there, then it applies and creates it, right? And this is secret, right? While you are creating all, you need to connect to my account when you create something, when you add something, when you make changes to something while deploying something. So for that, you need to set this up. Obviously, you can see it uses the registry names, namespace, and other things. It requires this AKS set context to be set beforehand before you do this, right? So this is nothing but a simple way to make sure that your image pull secret is ready, and you can pull the secret, you may pull the image and use it with the Kubernetes cluster. And this is a case deploy. uh, this is very interesting because it has a lot of components to it, and you can see it uses the manifest file, which is the YAML file, which is defined. We will go through that YAML file just for understanding purpose. And there is images which we created at the top, right? Whenever we are running this build and push, the image is getting created in the registry, so we are using that. And then there is a secret which we created to connect to the cluster, and then there is namespace which we created the namespace, or if it is for the first time, it will verify. If it is not, then it will just use the namespace which is already been provided. So all these are provided in the environments, right? So there is a namespace I've already provided here, there is cluster resource group, everything I've provided it in the environments. And the easiest way to use the structure of this environment is, you give the dollar and flow brackets, and you will be able to call those environment variables here. And so some of the environment variables are secrets. Secret dot registry name, which was defined in the settings when I showed you the secrets, how it was setting it up. So that is something which was happening there, right? So this is how it is done, but I will show you this one. Why? There are two things I need to show you. One is this one and deployment.yaml. I'll show you the, you know first is this specific one, because understanding of that will give you, we can see what it means. Okay, so there is cluster k8 deploy, and you can see here also, yeah, action.ml is there. But you go through this file, there is bunch of things you can do, right? It has with all the examples, but obviously see there is different kinds of examples which is out there. I'll show you one such thing, and then we'll go deep dive into it. So see, there is bunch of things in this while you deploy. So one is obviously, you can see there is a true and false for each and everything. So a couple of things, if you don't provide, it will go into default. A couple of things, there is no default, you have to provide. That is manifest file, what is the deployment file, you need to provide. Images not necessary, secret not necessary, because anyways you would have set the context, because it surely uses the context to do the certain things. And you can see this, most importantly, the strategy. So deployment strategy, so you can set values, none, canary, blue, green deployments. So there are different kinds of deployment strategies which you can use when you deploy code to Kubernetes, right? So this is one way of doing it. And this is this is routing method. Basically, if you're using blue green deployment, you will use the couple of routing deployments, and buffering and other things, traffic split. So basically you're splitting the traffic, how you want to split it. And obviously there is percentage traffic split when you do the canary deployment. Lot of things you can provide when it is based on your strategy of deployment and other things. So I'll just spend some time on deployment, because as a DevOps, you need to understand how, why it is to be done. So whenever you do Kubernetes deployment, obviously you will do four things, right? One is you will create it for the first time, so it's basically entirely new pod which is getting created, or you either update the desired state, you change the desired state and you roll it out, and then there is a new replica sets gets created, and then there is a rollback where you will roll back the code whenever you push the code, you feel this is not the right code to go into the production, and you will roll back the code. And then there is scale, where you scale your services, whether number of pods which is running, you want to add more pods to it, or more things to it, so that you can more nodes to it as well. So that is something which you can build on it. So there are a couple of strategies which is there. So I'm going to just walk you through those strategies. And as I showed you, while doing the deployment through GitHub Actions, you can enable those actions like this, when whichever strategy you want to enable, you can enable here. So this is a normal deployment strategy, that is new version of pod comes in. Like if you see here, new version of the pod, version 2 comes in when you have deployed version 1, new version of the pod coming in, and then there is update, when it will go live, and it will kill the other pods which is there. So we have discussed this as well in previous, where we did a Kubernetes deep dive session, where how does it happen, like liveness readiness check, different state checks, and what is the 30 seconds is what the old version will be there to make sure that all the request which is there, it serves it and then dies. So this is how a pod is getting updated in a simple way. And blue green deployment is basically a couple of pods, couple of versions of new versions, that is blue, you call it blue, and it is there in your Kubernetes cluster. And then there are a couple of pods which is in the which is in the green state, which is, that means it is usable state, and the new version is in the blue state, the old version is in green state. And you make sure that you test the blue version in production itself, and then you release it, and then you slowly kill all the green versions which is out there. So green version is stable version, obviously it is already running and it is all stable, and there is blue version which coming in, and then it both are there, you test it and you kill the ones which is not required, right? And then there is canary deployment, which is where you release couple of pods to only couple of people, that is customers, who can test it out and run it, run couple of workloads on that and see how it works and other things. A/B testing is also similar to what Canary is, but it has more specific use cases. Like it is built for making sure that how scalable this version is, and making sure it has different kinds of distributed systems. Like if you read through that, you can see there is geo operating system, filtering of traffic and other things. So it's basically, it has more power when compared to Canary, but both are almost similar to each other. So this is how the deployment strategies are to be built. And when we see this in action, this is basically, you can put it here. I haven't put it here, I'm using the normal deployment here, but in a real world scenario, when you're building for production, you will use different kinds of deployment strategies for that. And coming to the deployment file itself, right? So let's see, where is the deployment. So this is the Kubernetes YAML file, where you're telling this is the desired state, this is what I want, and this is something is submitted to the API server of Kubernetes, and Kubernetes takes this, builds a plan for execution, and it executes it. So this is a very simple, straightforward YAML file, and it has a couple of things. You can see I'm using Redis, and obviously there is RabbitMQ, Redis, and this is something which we did build. This is the first version, by the way. So when I pushed it and tested it, I tested it with the first version of it. But when you do it with GitHub Actions, it creates subsequent versions of this particular version, right? So I've added all those images and all those things. This itself is a full 1 day talk, like how to build this. So we did a couple of discussions when we did the deep dive session, but I just wanted to show you this how exactly has been set it up. I've used service kind, and I've used the deployment and deployment kind as well. So it's basically the workload types, different types. The service kind is used to it's kind of a load balance. It's used to connect to the different pods which gets created under this. So for each and every service which I have defined here, there is a service kind, and only front end will have the load balancer, and it has a load balancer attached to it, and it is on port 80 so that I can connect, and it is exposed. And that is what you see in the uh, in the in the things which we did, right? So where is the command which we executed? Yeah, this one, get service, right? So in this command you can see the only front end is exposed on a load balancer, right? That is how you define it. This is the structure you define, and it takes in this and it executes it. So anyways, this is how you can define, you can structure it, and it is already structured. And now we will run this. We have made change to code, by the way. We did change to code, we did the changes to the code. Let me go back to the actions, and hopefully this will run without any issues. Let's see. So I have, let's see how it goes. Okay, I am running this. So from a GitHub Actions perspective, it downloads all the actions first, all the actions, which means there were a couple of actions which I used, right? So there is context setting actions, KS deploy setting action from Azure, right? So those all things it will deploy. I mean, take it in, and it deploys, and it is just going there and deploying it. It needs to build the code for all of these different services we have. Not necessarily you have to design it in this way. Basically you can separate the different code into different actions, right? And only I did changes to only front end code. So I'm supposed to run only front end code deployment build, right? And it's building everything is not the production designed. So since I was coding, I put it in one code, but in a real world scenario, just make it separate services, build it, and then deployment of that. You can call the only deployment script as a separate one, and it will be two jobs. One is build and deploy. So it will be a different code altogether. I mean, GitHub Actions altogether. But I have used both in one. So while this is happening, while this build is happening and it is pushing the code and it was doing all these things, we could go back and spend some time on the cluster. So I did talk about monitoring systems and logging systems. How do you enable that for the cluster, right? So there is cluster I have, and you just need to, while creating cluster itself, you can go back and do the you can go back and set the context, right? You can go back and set these things, but you can also enable it once it is been set up. So while creating the through Terraform, I didn't set it up, and I went back and enabled all of these things after creating it to Terraform. So that is the reason there is a difference in state, and it is not through Terraform itself. So that is the issue there. So anyways, so I have the insights, different insights. I insights is basically trying to understand from the cluster perspective what's happening in the cluster and what is the maximum CPU utilization, memory utilization. These are very common things which every DevOps engineer or anyone would go back and see, like what is happening, what is the number of active pods running in a session and other things it will see, and it will make sure. So it is 25 now. Interestingly, it is 25. um, I hope okay, let's see. Let me just change this to pods. Cool. So if you see, the new versions are coming, new old versions are getting terminated here. So that is the reason why it is increased and it will reduce. Anyways, this is happening, and there are a couple of things I have enabled. When you enable Azure monitoring for containers, you can see what's happening for different services, how it is using CPU metrics, what are the CPU usage of these different things and other things which is required. But very interestingly, I have created a alert. So if you go to alert, see it is showing me one alert. Why it is showing me one alert? Two warnings, in fact. So why it is showing me one alert is because I have set up the alert in such a way that whenever there is a number of pod increases in number of pod in ready state, whenever it is increasing, uh, basically I have set it up in a way that increasing in the to do namespace, I have set it up in that state. So in whenever there is an increase, if you see this namespace, right, to do dimension, whenever there is a change, let me change the alert state. No, how do I? Okay, timeless severity 2 is this way. Alert rules, sorry, I have to go to the alert rules and then click on this. So now I can make changes to the alert rules. So if you see, whenever the total number of pods in ready state is greater than 9, I should be sent an email. So I have set that like condition, I have set the action, what an action needs to be taken. The alert action is one email. I need an email for this, and specify the warning severity and everything. So I have created a rule and I'm using that rule. So you can see that it's already throwing me a couple of errors and other things. What the warning which I had set it up, so it is throwing me that error. It's clear that there is number of pods is obviously more, and it is doing that. So it has reduced now 1 2 3 4 5 6 7 8. So since it is 8, it should the alert will it should reduce, because I have set it up for 9. Hopefully after 5 minutes this will be reduced. Okay, so that's about the alerting system. So you just go here, create an alert rule, create an action group, add yourself what needs to be done from an action perspective. When you create an alert rule, you have set of rules which you can select. I have selected the number of pods, but you can do a lot of things are available out there already pre-built for you. So you can just set it up, and it's like an alert manager. So you are setting it up. If you are using Prometheus, right, it's an alert manager kind of a thing where you go and create and you run it, right? So that is something which you can set it up. And then there is metrics, and you can use metrics for various things. You want to learn different metrics and other things. I have created a couple of metrics. um, it's on my push it on my dashboard. So you can see here, created a couple of metrics: active pods, which is running, the pod count, number of pods, which is there as an average, and CPU usage, and what is the health state of the deployments which has happened on the Kubernetes. It is healthy or not. So all these metrics I have from a metrics perspective. I've created it and I've added a new dashboard to it. I can see all these metrics together and see what it is, what's happening with this metrics, right? So this is the monitoring system which you can enable, and there is obviously let's go to back to cluster. The cluster here, and the cluster here in the logs, I can see the logs. I can set up the logs. It is already having all the services resource types, so basically you can change based on your resource types and other things, and there is already a couple of things which you can run. And if you just say alert run, and it will show up a couple of things here, and you can see the CPU usage and other things, what is happening from the log perspective, right? That is as well available to you for each different time, right? So you can build a query. It uses a query language on its own. It's called K query language, and you can use that to build yourself a query, and you can also use table structures and other things. So logging is here, and there is metrics, there is alert, there is insight. Everything is available from a Azure container, Azure monitoring for container insights. This is a specific service which is available out there, and you can use it. Obviously, you can use this with Grafana, which we did last time. You can use this with the Prometheus as well. Prometheus is to very similar. It takes in the data from the application and puts it onto its it has its own query language like we have, and it runs those query language, and alert manager of the Prometheus picks up the metrics. These are all telemetry, so it is picking up the time series data, and it is showing us some alerts what is happening in the system. So that is from the monitoring system perspective, but there is policies which I talked about. That is the most important one is I've enabled the policy. So this basically I enabled after spinning up. So this is why the error was from the Terraform, that you have enabled it outside of Terraform. So that is the changes you have made. So basically if you see here, the service is currently enabled, and I can see what is the output of the policy, what is the compliance of my service. So I haven't created any new policies, but you can create like this. You can say assign a policy, and add different resource which you want. Say for example, I want this for my container service, and whatever the Kubernetes service. I don't want it on alert manager, I don't want it on pods, is okay, I don't want it on storage. I can select it and save it, and it gets saved, and then you can define the policies which you want to pick. So there are custom policies you can build. There are built-in policies. You can basically see what are the policies are there. So if you see, there is already, like, you need to have a private cluster. You can say policy add-on policies needs to be installed. What is the IP range, what is the defender. So there is bunch of one. If you see, 49 policies are there, and you can enable different policies based on your requirement to make sure that your cluster is in compliance. You are not going away from the compliance of this specific policies. So you build those policies and keep it. So it is part of the DevOps, because you are managing the DevOps, right? It's basically code is there, security is part of DevOps. So that is the reason why DevSecOps and other things is part of this. All these are automated, right? These are all built-in custom policies. So when you select these policies and put it onto the system, you can actually see that it is making sure that it is taking end-to-end, taking care of your cluster. So this is what we want to do, right? So now I have a cluster. I built it through Terraform. I have code. I've pushed the code. I don't know what happened to the code. Yes, we have pushed the code. It's all built. It is here, and it has run. So we will see, where was the code? It's here, right? We had this thing, and it is getting refreshed on its own the moment I came here. So you can see here the code gets changed. So the code is here, and I didn't push it directly to the Kubernetes. I did use the GitHub Actions. I built it. I set the context. I have run it from in a different namespace and have done all the things which is required from an execution perspective. Right? It is all automated, and that is the reason why it is so important to build it through DevOps. Right? I have code, push the code, and if I had set it up as on push on GitHub Actions, everything would have run automatically, and each and every services, if I had separated it out, it would have run even much faster, and then it would have pushed the code to the production environment, and now it is available with the customers, right? And if I had selected different kinds of deployments as we discussed from the strategy perspective. So if it is different deployment, that means only a couple of customers would see different things from a canary deployment, from an A/B testing deployment, from a blue-green deployment. It would be a different kind of deployments on Kubernetes, right? So that is what exactly the structure will look like. So let me go back and let's do a very different thing now, which is the most important thing, which is developer specific thing, right? So what is developer specific? That means developers have different services. So I have a cluster of say for example, if I'm running 25 microservices, and I connect, I'm working on a specific microservice which connects to 5 to 6 different microservice. I don't want to create a cluster. I don't want to build those servers, build those code onto my laptop and test it out, or test the changes I make, all those things, right? How do I do it as a as a developer? How do I make those changes? This is nothing to do with DevOps, but it is still a workflow for DevOps, and it's more important from a DevOps engineer's perspective to set this up for them, to make sure that this is all up and running. So we'll see that how to do it, right? So we will go back. I will go to I'll make directory and say demo today, and I'll go and say demo today, and then what we will do is we'll GitHub clone. What we will clone the to-do app. I'm cloning the to-do app. The reason is I had already installed the dependencies, so I had to redo it. So let me go to app, and we have the to-do app now. So all we need to do is I have done the deployment of the code, and we need to open we need to go to the stats API. Okay, it's not there. Cool. So where is my VS Code? Perfect. So let's open in VS Code the code demo today to do app static stats API. I want to call stat API, that is the stat service, onto my local, and rest of the services are running on the cluster. But this is also running on the cluster, but it is creating a local setup for me using Kubernetes port forwarding. There is a concept in Kubernetes port forwarding where you can open the service, and using the root manager, you can actually access it through your local system. So this is the structure. This is how it works. And we will obviously do a deep dive session tomorrow. There is 45 minutes of this session tomorrow with Renu, where we are going to discuss about how do we do it, how does it work, what is the structure, what is the different things it does, and what are the steps it takes when it is doing, and why it needs to be done, what is remote, what is hybrid, and all those things. But from a DevOps perspective, just to understand how exactly it's to be done, I'm just showing you a demo here. So there is static, I'm bringing it up. I do trust this code, and while this is up, I need to go and open array. Why this is coming up? I don't know. I'll have to go and there's some issue. New terminal, and then I'll open this up. Okay, let me close this off. I open the new terminal. Okay, so in the new terminal, I'm just installing the packages, which is simple npm install package. Okay, I'm just installing the package and I've done the installation. Got it. Now, if you see, if you see at the bottom here, it is showing me cluster, which cluster I'm using, Kubernetes cluster, which namespace I'm using, and which is the bridge, bridge to Kubernetes extension. So bridge to Kubernetes is nothing but it opens up the local, I can call the service, right? So that's an extension on Visual Studio Code, and there is there is extension which I have. I mean, there is simple. I have the Kubernetes extension here. If you see this, if you click on this, you can basically select the cluster, which cloud, and that is Azure, and it can select the cluster. And in the cluster, I am selecting the namespace where I want to work. Right. So basically, I have this couple of namespaces. To do app is one of the namespace, and when I and okay, let me show you the other namespace. So if I have default namespace, if I right click, you can see here use namespace. So I already have, you know I already have selected the to do app. So it's already up and running, right? So I have the to do app and I've selected it. So let me go to the code. I have the code. I installed it. I'll put a breakpoint in some place just to make sure that we break the code here and see what happens, and see it's basically breakpoint I'm adding here. And then after adding the breakpoint, what we will do is we will create a bridge to Kubernetes configuration. How to do it? It's simple. You can either open it here, or you can use the shortcut keys which is there. So it's in Mac, if you're using short command P, you will open the command palette and you can just bridge to Kubernetes configuration. So it connects to your Kubernetes. How does it do it? Because you have selected the which cluster, which use space, which is the namespace and other things. So now you can see there is a namespace. So now you can see, the under the namespace what all services which is running, right? So this is the stats API I want to play around. I'll give the port. I will run a script which is a launch configuration. That is, this is what I need to launch while I want to run my code locally, and I'll say yes from my domain to reach, all requests coming from my domain. I want to open it here. So it takes in the configuration, it creates a configuration for me. Now I need to debug the code which is there. So I've added a break. So I want to debug it there. I'll come to debug button. If you see here, there is a debug button. Just click on the debug button, and it is already setting. It is already setting that I have created a launch configuration with Kubernetes. So all I need to do is select it and then just run it. So it is in debug mode now. This is So there is a cluster which is already running, and the cluster has the code, which is the to do app, right? In from the to do app, I'm pulling the stats API out into my local, and whatever code changes I make, I can see in the local, right? So I can verify it in the local, and it will also um, update that. Let me show this. Okay, so this is how it works. It's basically it's there is a deep dive session tomorrow with a lot of demos out there. This is just to show you how exactly you can fit all these things. It will ask you a couple of questions and a couple of things, permissions and other things which is required to create. So make sure you provide those permissions, and you can see there is couple of things it will do, right? Um, oh, it should have done already. So while it is doing, I'll show you what's happening at the code, right? So we'll see. Where is that command which we did pods. So when you see, if you see, this bunch of pods got created, and these are, if you see my local system name, stat API pods have been created. It will get it will get through port forwarding, it will get through routing manager deployment. It will be port forwarded, and I can use it from the local, right? So that's the advantage of using bridge to Kubernetes, where easier for me to I didn't download anyone's microservices, I didn't download anyone's code, anything. It is already running. Either it could be on dev system or on production system. I'm just picking that specific service where I'm working on as my setup, and then I'm still routing my request to the one which is running in the cluster. So that is the advantage of using this, and it is running now. It is already listening, and you can see there is a color change here from blue to orange, right? So that means there is no issue, and it is running on port 3001. So if I go here, where is the code? This was the code which was running, right? So now we can add bunch of add one, add two, add three, four, whatever, three. So three things we added, and we completed bunch of things. And when you go on to the stats, you can see the couple of things got created, right? So now I can see this on my local as well, right? So I'll show you how local host 3000 stats. If I give here, you can see, I can see obviously the UI and other things is I have not downloaded it. So you can see that, you can see this is the code that is, it is throwing me the JSON format. That is, this is because API, because I'm have pulled out only the API, not the front end, right? So that's why I'm seeing only the JSON format of the API, output of the API. So this is 4 and completed 3. So that's the, it's on the local host. I can see it on the local host. So that is the advantage of using the bridge to Kubernetes, right? So that is the whole thing. So we have, if you see this diagram, right? So we did, um, we had source code, built it through GitHub Actions, but when we did the other previous demos, we also used Azure DevOps, and then there was production environment or a Kubernetes cluster with built through Terraform, and you have it up and running, and then container registry, you are pushing it. You can also build scanning. Scanning is new technology where you container scans for security vulnerabilities and other things. How to build it? Uh, we have done a specific session on that. If you go to my Wikibytes and GitHub Action series, bunch of video recordings, source code, you can find all the things here. We did container scanning. So while you build containers, you can also scan containers. I'm not sure which one is the latest one, but anyways, I'll just open up. So here you can see, container scanning itself, Azure container scanning as action which is already available. You can just scan the container for criticality, whatever it is. uh, it will do the checks and other things. So you can add this as well. So basically even the container scanning can be a part of it, right? So we did see how bridge works, right? So that's one thing. So while we are here, before I go into questions or anything, there is a cloud skill challenge. It is limited time now. It is 15 to 20 days might be left out for completing it, but it has all the collections, all the things which is required for you to complete uh, Where is the code? Let me just copy this one, this challenge. Ta-da. I'll just show you what are the things you can learn through this cloud skill challenge. So, so cloud skill challenge is more about learning. So it has 18 days left. So yes, you can obviously complete it everything by December 15th. It has sandbox, it has learning materials, it has code, it has all the things which you want, the commands which you want to run to do all these things. So most of the things which is already 173 people have taken it. So please go ahead and you can take part into it. So let me log into my account. I'll show you the continue learning. So I'll show you. So it's basically starts with simple introduction to Linux, Docker, containerizing your app, how you should structure Azure. It's also build and store container image like how we did. It has detailed examples and also sandboxes. You can see here a couple of things you can do with containerized web app, and then introduction to Kubernetes itself is all available here. So it has pipelining, GitHub Actions, all I built, I showed you now. Everything is available here as a part of learning for you from Azure DevOps as well. So go ahead and take that up. It's kind of around 20 hours of learning. So just make sure that you take this up. That is one thing I had. And let me keep this open when there is questions. I'm happy to take questions if there are. Okay, let me stop this as well because this will keep running. So I've stopped debugging mode. Okay, so is this okay? So is there any questions out there? Okay, there are a bunch of questions. Uh, Yes, the shared links are already there in the check-in. If you do the check-in, and there is Cloud Skill Challenge link which Rashmit has already shared. There is question from Manish: cost saving tips. Ubuntu OS cost less than all other runners or GitHub. GitHub host runners cause I'm not sure with the costing perspective, but it is for it's generally a couple of things are free for open source projects and other things, but you need to check the costing, and it's not much, which I don't think so that will cost much from the if you are using your own runner. That means if you're using your own infrastructure, it's very difficult. But if you're it's going to get cost high. But if you're using it less, I think it's better. GitHub coming up, upcoming features. Uh, there's a bunch of things, yeah. To try any actions manually is coming soon, so we don't need to add workflow dispatch. Yeah, that is there, but today I had to do it because I did a lot of things. So that is the reason I did that. Anyone struggling on setting up GitHub repo actions, please okay. Uh, can we get this recorded video? Yes, you can. It will be on the YouTube channel, which is there. There is for DevOps, which one should I learn first? You can also unmute and ask questions, by the way. That's I'm just reading through the questions and probably answering those, but you can unmute and ask me questions as well. Rashmita, it's everybody having the options to unmute. I had
Yes.
actually. Yeah, okay. How did you assign IP address for pods and nodes? Azure? Yes, that is correct. It's basically while creating itself, you would set up the pod with services and other things. So, I didn't assign IP address to it. It is automatically assigning to it the moment you structure it in within the network, right? So it's part of the Kubernetes way it creates this worker and other things. So can you show me alert and metrics step again? Okay. Let me come back to that. Uh, okay. You can see my screen, right? Okay. You want to see alert? Let me go here, all resources, and go to Kubernetes. And in Kubernetes, there is alert. So if you go to that alert, it basically verifies. You can just go and create alert rule, and you can select which one. The rule is for Kubernetes cluster, and also you can select this edit resource. You can do it, and you can add a condition. So when I add a condition, I will have a bunch of things for me to add a condition. So you can select whichever. I have selected a couple of things, like anything you can select the way you want. Number of pods in ready state, it's aggregated, it is this. I want to ready state dimension. So namespace, I can add it equal to do app. Okay, so when I do that, it is 8.17. It's an average, so that is why it is taking 8.17. So if you see here, it's an average state. So there are other things like dynamic and static threshold. So very interesting concept here. When I say static, it's me who is setting it up. But when it is dynamic, if you see this, that notice here, it's basically a machine learning thing. So it does a machine learning of this, and it automatically sets the thresholds based on the whatever the threshold you are generating. So interesting concept, right? So basically it's that's the use case of machine learning in DevOps, right? It's learning learning your infrastructure, learning your what is happening at your infrastructure, and it is setting the threshold for you. And you don't have to be worried like this is what I need to previously we all are worried like if while I was DevOps, if this threshold is good to use or not. Even if I set this threshold sometimes, I would have overshot the threshold and other things. So I've set it up here and just done and save it, and you will save that. And let us save this up, otherwise greater than total number 10, and 5 minutes, check every 5 minutes and the thing. So it will tell you what it is doing. And then you need an action. So basically you will go and create an action, create a new action, and basically use different name for it. And then you just go and select what type of action you want. Either you can do an action through various things, Azure Resource Manager roles, and or you can use this where you can select your email address, SMS. Obviously there are different things. You select other things, and you will get an email to it. So this is how you can set it up, and it will set it up for you, and it will keep sending the mails whenever I'm getting mails for the alert which I have set it up, right? And its metrics is also the same. So there is no change in the metrics UI. So you just select the scope, the which metrics you want. This is the same thing, very similar to what you do with Prometheus, right? So basically container pods, and you will say pod count, and it will start showing you number of pod count at an average level, and you can say maximum or minimum or an average level, and it will keep running it, and you can pin it to dashboard. So you can go and pin it to dashboard, and you can create a new dashboard. I've created a dashboard, and I can pin this to the dashboard, and I will have a dashboard for myself. DevOps engineers, you love dashboards, right? So it's basically you can see if there was more activities at an average pod numbers were increasing because a lot of activities I was doing, and CPU usage, a lot of activities, whether it is healthy or not. So all these things is available for you. So that's how you're going to use it.
Hi,
Any?
Vivek, this is Darshan.
Yeah.
I have a question actually, like it's an out of the box question. So if you want to take a certification for this one, right, DevOps, so we have multiple options. Like we can go for Microsoft Azure, or like and we can go for like Amazon AWS as well. So how can we decide upon like which one is the best option for us?
See, basically, DevOps is DevOps. What I would say is evaluate based on your what you want to do. So if you see Azure DevOps certification, specifically the AZ 400, it's not just the DevOps questions and Azure DevOps specific things, right? So it's more of journey. DevOps strategy and other things, and also there is GitHub Actions to it. GitHub Action is independent of things you do, and it is GitHubs, right? So it's basically you built everything on GitHub, and you want to run events which will happen on GitHub. And if you see this, right, the structure now, right, the infrastructure as a code is on GitHub. So everything I'm running it on GitHub. So nothing I did manually, everything was automated. Like everything is running through GitHub only. So it is independent of any cloud. So which is the best option? I don't want to give like this is the best option or that is the best option. It's basically you can evaluate based on which one you want to go for. If you have I mean if you have skills on Azure, you have skills on things related to Azure, go for Azure. If you have skills on AWS, you can go for AWS. But it is also good to have cross skills in to make sure that you have the knowledge of both the things. Like if you ask me, like I know what is happening in AWS, right? How AWS is structured, how to do it, how do AWS uh, DevOps works and everything. And also I know Azure DevOps and GitHub Actions. So it's basically it's having both the knowledge is good.
Got it. Got it. Thank you.
Any more questions? Any more questions you have, or you can just go and take this. And whether if you have any questions, also you can reach out to me on my Twitter account. And if you have any questions, just ping me on LinkedIn, Twitter, and probably you can also attend tomorrow's session where I'm going to talk to Vishal Biani. There is ML Ops, ML specifically how to build an ML project and deploy it in Kubernetes. What changes there, so you can obviously go and do it. And Amrish is coming and talking about it. Renu is going to do a deep dive session on the bridge to Kubernetes. She has a better demo than what I have, so that you can obviously understand both the things. So there is a question there. Can we please have the link to MS Learn? Yeah, I can do that. Oops, I can do this way. Uh, did I skip?
Timing Vivek. I have shared.
So Vivek, like what time do we have the session tomorrow at the same time?
It's no. It starts at 10 in the morning.
Okay.
Maybe you could, because you have attended this session. Maybe you could join in at 10:45, because some of the things I'll be redoing it
Mhm.
there. But obviously, the session is about first session is about. Let me share that as well.
Yeah,
So
sure.
the I can share it in here. So my mouse is playing games today. So this is the Kubernetes Day. There is an agenda for it, and um, so it's Kubernetes Service Workshop. When I say Kubernetes Service Workshop, a couple of things which I spoke today it is there, but while setting up Kubernetes, what are the things you need to take care? what is that Azure CNI and all those things. I'll go deep dive into it, and obviously we will deploy code and we will see how to deploy, and we'll run through a couple of examples and things like that. But it is just a 1 hour of discussion on specifically on Azure Kubernetes. If nobody understands the Kubernetes as a structure, as a, if you're first time to Kubernetes, I'll also talk about the architecture and everything, and then go in deep dive into it. So that is what it is. And bridge to Kubernetes, I told you, Renu is doing. It's a good session. But the most interesting session is also with Vishal Biani, right? So he's a CTO, and I'm going to have a chat with him on various problems on Kubernetes, not just challenges. It's also in roles and responsibilities. What is mean for developers, right? So all those kind of questions. It's going to be an interesting chat with him, and obviously Amrish is going to do it from a machine learning perspective, how to use it, different services, how to build machine learning models with the AKS and other things which you can use. So if you want this link, I'll just share it in the chat.
I just did, Vivek.
Oh, okay, it's already there.
Yeah.
Yep.
Sure. Yeah.
Arun this
Thank
side.
you, guys. Thank you, Rashmita. Thank you, Vivek.
Thank you. Yes, somebody had a question.
Yeah, hey Vivek, Arun here. So yeah, thanks Vivek for just such a wonderful session. I think I've been attending a lot of your session. I was part of the Conf Hub conferences as well. So yeah, nice to see you again. I have I've been this DevOps enthusiast. I have been doing a lot of DevOps, and majorly I've been doing it as a part of a classic editor kind of using the existing tasks and all. So I am not much, I've done the Kubernetes deployment and all as well, but coming it to the coding part of YAML and all, I'm not much familiar with it. So it's I haven't gone deep dive into it. What is YAML and all? I know. So I just want to like, how can I get professional in YAML and do a lot of start moving my pipelines from classic to the YAMLs, all the pipelines. How can I learn that? Can pick it up.
Yes. So, see, YAML development comes through, it's basically a practice, and it's basically you doing it daily. Okay, so building something new and pushing it, and it comes to you very easily after that. And every time I see new things in the YAML, it is very different, right? So say for example, if you want an example, um, I think I did share the sock shop example in my um, not sure whether it is there here. Okay.
Vivek, I'm just looking for like, where should I start it from? Is there any learning material anywhere? A good kind of
It's
labs only on lemons?
Yes, so it's always to start with, you always start with the Kubernetes documentation. Obviously, it has a lot of things, the problem is it has a lot of things. Each and every YAML has different things, and a lot of controllers have come in. So the controllers itself will have different kind of a structure, not a structure, but different, different fields to it. So it's kind of you have to keep playing. It's like practice makes man perfect, right? So
Okay.
that's the only thing which I can tell you. There is no starter. I mean, starter is always there. Starter is like you go and go to the simple quick start, uh, quick s- quick start for Azure Kubernetes, and if you go here, right, there is a starter YAML. Like this is a simple YAML where there is a deployment kind, and there is require CPU and all those things, and there is services. But when you have to do this auto scale, how do you do it? Itself is different, right? There is a different
Right.
auto scale YAML file where you will add the minimum maximum number of pods required and add it on top of things. So there is a different structure to it. So you keep doing all these things, keep working with different examples and playing around with it, then you will be able to work on it. So I'll also say, if you uh, try and see if you can run it with play with Kubernetes. There is where you can spin up cluster and play around with it.
Sure, Sridhar. Thanks. Thanks.
So Vivek, so to continue on the same question, is there any platform or where we can have a practice hands-on these Kubernetes and clusters?
Azure.
Azure, I mean, in the labs, or there are different parts like documentation
Yeah,
lab.
you can use Azure AKS, or you can also use if you go to this Cloud Skill Challenge, right?
Okay.
You also get a couple of things in the sandbox to play around. 4 hours it will be available live for you.
Okay. Is there any guided kind of
Yeah, it
lab?
is good. Yes, it is. So if you go, as I told you, right, this challenge which I showed you, the DevOps for All challenge, if I go and continue, so let me show you this Kubernetes introduction to Azure Kubernetes Service. So there is a sandbox kind of a things you can do.
Yeah, adding to Vivek, like this
If you
MS
see here,
Learn are very, very good labs. It has
yeah, so
everything,
you
with
can
a
learn everything. I have another challenge which I'm going to launch tomorrow as well. So if you see this is only for tomorrow launch, and there is only 14 days to do it. But that is specifically if I have to join this challenge, and let me show you what I have handpicked this one, because if you want to learn Kubernetes, I think this is an amazing example which it has. I can share this tomorrow as well, but anyways, I'll share it with you. So if I go and continue learning, it's only 2 hours of workshop. So there is a workshop, and if I go to this workshop, it has everything you need from a production perspective. It is it's a gamer, like it has exercises, so you can play around with it. It has code, everything is available. So as an example, what you will be deploying is this. This is amazing. Like you have Let's Encrypt, you have certification manager, ingress controllers. You will learn, like, how exactly these services gets enabled. There is backend services, there is load balancer you are going to use, monitoring and registry, everything. So all these things will come together in this specific example. It has code for you. There is GitHub repos, so you can play around with it. And when I say code, GitHub repo itself, you can basically um, see the complete doc. So basically you can build the Docker file. You can build it and push it to push it to the container registry, and obviously run through it. Okay.
Thanks. Thanks.
thanks, Vivek. That looks awesome.
Yeah, I think MS Learn will help you with this.
Hi Vivek, one question. So my question is, should I need to learn Terraform? So is it a higher version of Kubernetes, or can Kubernetes can do all these activities without Terraform?
See, Terraform is infrastructure as a code. It is about provisioning your code, provisioning your infrastructure through code, right?
Okay.
So basically, say forget about it, Kubernetes. Say simple VM you have. Say as a person one, you have any VM which you have used, like created a VM for say 4 CPUs and some 8 memory, right? 8 GB memory and things like that. So you created that through Terraform. So you coded it and used the provider and other things, and you did the code, you created that. And that state of that particular VM is saved in some location. And as a user too, I pick that state. I don't have to pick it up. I just have to run my Terraform code. So Terraform do is it will go and connect to the storage. It will check whether the state is changed, and when the state is changed, it will apply that state change state. So the user two, if he has changed the state from 4 CPU to 7, or sorry, 8 CPU or 16 CPU, and then memory to something else, 32 or something. So it changes the complete VM state, and while it is changing the state, it won't or anything. Right? So that is Kubernetes. Sorry, that is a part of the Terraform. Terraform is more used in managing your infrastructure through code.
Okay. Thank you.
So Rashmita, are you there? You can. Oh yeah, this is the survey link. So please provide your surveys and use the check-in. Please enter the code which is there while you do the survey, so that we can make sure we provide you with good content. Whenever we do the content, it has to help you to upskill yourself and also upskill myself. So I did all these things with a lot of learning as well. So for me as well. So that's something which is there. So any other questions we have? Cool then.
Hi Vivek, am I audible?
Yeah.
So I have one question, like starting my career as a DevOps engineer for a fresher. Is it a good decision or not? Actually, means I am working as a DevOps engineer from last 9 months as a fresher itself. But I'm not gaining confidence in myself in order to provide a good solution to the client. So, is it a good decision to start a career as a DevOps engineer, or shall we follow the traditional path like become a developer, work for 3 years or 4 years, then move to a DevOps point of view? So, what is your means? Any suggestions regarding this?
Yes. See, it's a good decision. Don't worry about the decision. It's just that maybe maybe you need to spend more time in understanding the core concepts and other things. Not everyone also can, even a very experienced also cannot give good solutions to people. Sometimes even it's not always like I have right solutions every time. So there is obviously there's thin line, so it's like you need to spend more time, more hands-on, more learning, core things, right? Very much important is from a DevOps perspective, the core thing is very important. uh, Linux, specifically Linux, using bash scripts, using how to make sure you unearth things. The core is all about monitoring and log management. How do you build analytics on those things? And then there are bunch of tools in DevOps. This, don't worry about uh, things like that. So pick up those. Everything does the core job, right? Every tool which is there, it does the same thing. Like if you pick Jenkins, it does the same thing. If you pick GitHub Actions, it does the same thing. If you go pick Go CD pipeline, everything does the same thing. Even Azure DevOps, it does the same thing, but it has different concepts, it has different ways to do it. That's the only different, and maybe one tool is better than other tool in different situations. You will gain confidence based on the more you learn, more you read, more you do hands-on. That's something which you will anyways gain, but it is definitely a good decision. As a fresher, you are already in DevOps, which is good.
Yeah, thank you. Thank you.
Let me share that link to exercise. Just give me a minute. Where is my? Why I'm not able to? Okay. So. Any more questions we have? Apart from that, while I share those link. You can type in the, I don't know what's happened to my laptop. Got it. So whew, there was any, that's the link to a couple of things. Okay. Rashmita, I think we can close the session.
Absolutely. Thank you, Vivek, so much for the session, and thank you all for joining us today. Please feel free to do event check-in and share your feedback about today's session. And please visit Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again and enjoy the rest of your day.
Thank you. Thank you, Vivek.